This is called a heating curve. I know it doesn't look like a curve, but it is still really useful. Let's talk about the X and the Y axis first of all. So going across the X axis, we are adding heat or energy. So as you go across, there's more and more heat being added. And then the same thing with the Y axis, as you go up, it's increasing. And in this case, it's increasing the temperature. So this one shows us that if you start with an ice cube, and how do you know it's an ice cube? Well, it's negative maybe 75 degrees Celsius here. So water's going to be an ice cube here. So we have ice, and then as you give it energy, that ice is going to heat up. And this is a weird concept because you're starting off with very cold ice, and then you're heating it up until you have relatively warm ice. Now it's still below the freezing point, but this is much colder than being somewhere close to here. All right, so we're heating up that ice, and then we get to 0 degrees Celsius, which is where ice melts. Okay, so now while we're putting heat energy into it, notice how the temperature doesn't go up anymore. All the energy is being used to convert that ice cube into liquid water. So it's going from solid to liquid. We call this a change in state. Now, this first one we talked about here, this was a change in temperature because temperature was going up. So once we're here, now we have liquid water. All right, so we have liquid water. And as we keep on giving it energy, we keep giving it heat, what's going to happen to that liquid water is it's going to heat up until it gets to 100 degrees Celsius. And once it hits 100 degrees Celsius, any extra energy that you put into it is going to be used not to heat it up, but to actually change it from water to steam. So here we're starting out with liquid, and then we're going to end up with vapor. And then this again is also a delta S, a change in state. After all of it has been changed to vapor, then it's going to heat up. The temperature is going to go up here, and you'll have hot steam or warmer steam. Now it's getting to about 175 where it looks like it's about ending here. So again, just like with the ice, this steam is going to be warmer than this steam, which is at 100 degrees Celsius. It's the same idea as you can have a hot glass of water or you can have cold water. The same thing's true with ice cubes. You can have colder ice cubes or warmer ice cubes. All right? Okay, so this is the heating curve. And what it basically tells you is how much energy it takes to do each of these sections. So if you have ice and you're warming up ice, you can figure out how much energy it takes to heat up that ice. You can actually calculate how much energy it takes to go from ice to water. You can calculate how much energy it takes to go from cold water to warm water, or the change in temperature there. You can calculate how much energy it takes to go from water to steam. And then finally, you can calculate how much energy it takes to go from a cooler steam, maybe at 100 degrees, up to 175. So the goal of this is to come up with a number. And that number tells us how much energy it took to go from that ice cube all the way up to that steam at 175 degrees Celsius. You can also do the opposite. You can start as steam, cool the steam off, and then it would look just like this chart, but it would be in the opposite order. You'd start at the top and then go down. So it would look something like this. All right, and you can calculate that as well.